After the tone, please state your name followed by the pound sign.
Mapping running on a Hadoop environment, either from developer or from PowerCenter machine. And Ravee will walk us through a demo on how to create connections, whether it's from developer or from PowerCenter, and we'll look at running a mapping, having Hadoop or Hive source targets from both the places, developer and PowerCenter. And we'll also look at where to look for the logs in case of, how to monitor the jobs that are running and where to look for the logs. So what is Hadoop? Hadoop is a framework. It's fundamentally an infrastructure software for storing and processing large data sets. That means that, you can buy a whole bunch of commodity software servers, but then put them together on a rack and run Hadoop software on each of them. So it's designed to be on a commodity server, and it's designed to run on large number of machines that don't share any memory or disks. So the storage system is not physically separated from the processing system. And Hadoop is an open source project of the Apache Foundation. Hadoop uses Google's MapReduce and file system technologies as its foundation. What is Hive? Hive is a data warehouse for the Hadoop framework. And Hive facilitates easy data summarization and ad hoc queries and analysis of large data sets stored in Hadoop-compatible file systems. So what does Hive really do is it provides a mechanism to project structure onto the data, and it also facilitates the ability to use a SQL-like language, which is called the Hive query language, to convert any Hadoop job into a MapReduce program, a MapReduce function. Some important terminologies related to Hadoop. Most of you would have heard HDFS and MapReduce along with whenever we talk about Hadoop. HDFS is the file system for storing data, and MapReduce is a program where there are two things. One is mapper and reducer, two functions which are written for processing large data set. Here, the most important aspect of Hadoop is that HDFS and MapReduce, they are designed to work hand in hand. So each of them are co-deployed such that there is a single cluster, and it provides ability to move computation to the data and not the other way around. So that helps with improving performance. Let's look at Hive components. Here in the picture, we see the various Hive components, which is the command line interface or the web UI, and that is what is submitting the query to the Hive. And the driver is the important part of the Hive. It creates a session handle for the query and sends the query to the compiler. And compiler parses the query and generates a plan. Metastore is a warehouse for the metadata, so it stores information about Hive tables and schemas. And execution engine is the one which actually runs the plan created by the compiler. Let's look at Hive Metastore. Like I said, Hive Metastore is a central repository for Hive metadata. Now, there could be three different modes in which Hive Metastore can run, either embedded, local, or remote. Embedded means the Metastore service is in the same JVM as the Hive service. However, local Metastore separates the database, meaning the Hive service runs in the same process as the Hive service, but it connects to a database which is running on it as a separate process. And a remote Metastore is the one where one or more Metastore servers run as separate processes, and it is separated from the Hive service itself. One important thing to note here is Informatica does not support if you have embedded Metastore setup. Here we are showing some of the Hadoop distributions that we support. So a Hadoop distribution is more of a customized package of the Hadoop itself. Like initially I said, Hadoop is Apache Foundation initiative. So vendors like them, like the one here, they create customized packages and provide it as a Hadoop distribution. Coming to Informatica, so Informatica lets the Informatica Big Data edition lets you use the entire Hadoop architecture and make use of the distributed processing concept, which helps in processing of large data sets across commodity servers. So the three important things you could do is access big data sources, especially the unstructured and semi-structured data, social media data, and data in Hive and HDFS. It helps you replicate data, and it also does push down, which basically distributes the mapping and also the profile jobs, which could be very resource intensive. So that could be pushed across clusters on nodes in a Hive environment. Let's look at Informatica Big Data product breakdown. So we hear about a lot of names around Hadoop and HDFS. We wanted to show what each of them means. Power Exchange for Hadoop, it integrates PowerCenter with Hadoop to extract and load data. So it's on the PowerCenter side, wherein you have a run on the PowerCenter repository. And Power Exchange for HDFS is for connecting to the HDFS, the file system, from developer tool and run mappings using the data integration service. Power Exchange for Hive is also on the developer side. It's for connecting to Hive and run mappings from the data integration service. When we say push down, it can be done only on the developer mapping. It can be done only on your data integration service machine. And this push down basically means that you can run the entire mapping logic on the Hadoop environment. So all of these are licensed options. And when we say Big Data Edition, it refers to all or one of these options depending on the license that you may have purchased. Here is the product availability metrics. As you can see that Linux, SUSE Linux and Red Hat Linux are the only two supported operating systems. And we are showing some of the Hadoop distributions and the versions as of the latest 9.6 release. With that, let's move over to installation and configuration. The software install itself. PowerCenter Big Data installation is provided as a RPM package. The RPM package includes the Informatica engine and also the adapter components. So the RPM package should be distributed on all the nodes in the Hadoop cluster. We need Informatica binaries to run, to be available on all Hadoop nodes where you are going to probably push down. So that is why we need the Big Data installation RPM to be on all the Hadoop nodes. For specific steps on how to install this RPM or how to distribute the RPM, you can refer to the installation document, the Big Data Edition user guide. So like I said, RPM is a subset of the DTM libraries that are on the data integration service machine itself. So basically, we have some libraries that are required to run a Hadoop job on the other Hadoop, all the Hadoop nodes. During the installation, so here we are outlining all the steps that you need to get Informatica mapping running on the Hadoop environment. So you need to have installed all the third-party libraries that are required for any mapping to be successful. For instance, if you're connecting to Oracle or if you have some ODBC connections that you're making, then you need to have Oracle clients and ODBC drivers to be set up. Likewise, if you have a data quality mapping, then you need to take care of a native connectivity to profiling database and also the content database for data quality. And Hadoop cluster with supported version should be installed, and also a supported version of Hive should be there for the Metastore. The other step that is required before you run a Hadoop mapping, push down a mapping from the developer side is the ability to, to look for the Hadoop directories for the data integration service. Here I'm showing the execution options in the screen print for the data integration service. The data integration service Hadoop distribution directory, it's the last but one property there. This is the path on the Informatica server machine. This contains the folders that I have listed in the second screen print, which is infalib, libconf, infaconf, and scripts. So these are the binaries that are required. Lib will have binaries that are required for the Hadoop jobs itself, and infalib are some customized libraries which Hadoop will not give out of the box. And then conf will have hivesite.xml, which is the configuration file required for the Hadoop jobs to run. And infaconf has some, the environment related property files that you need to configure for Informatica to be successful on Hadoop. So going back to the first screen print, you will see the Informatica home directory on Hadoop. This is the path on the Hadoop nodes. The PowerCenter Big Data Edition home directory on every data node created by the Hadoop RPM install. So it has to be the Big Data Edition installation directory on the Hadoop nodes. And the Hadoop distribution directory itself is a path again on the Hadoop nodes. By default, we write it to Informatica/services shared Hadoop and the Hadoop distributor name. The other required configuration is on the client side. You need to change the developer core.ini. The property name here is dinfa_hadoop_dist_dir. This is the Hadoop distribution name of folder path on your client machine. So why do we require that? It's for mostly when you import the Hadoop, the Hive data, that path is required for the importing the metadata part. The other configurations that needs to be done after you install the RPMs, you have to perform this mandatory step on the Hadoop nodes. You need to update the cluster configuration file, which is mapred_site.xml, and remove the Java option. And similarly, which is mentioned here, the child.java.ops. And after that, you have to edit the Hadoop env.properties, which I spoke about in the infaconf directory. And you need to include the Java library path as shown here. This is again in the document, so you can refer to the document to see what are the exact steps. You also have to do the content, the reference data files installation. So on all the Hadoop nodes where the data integration service will run a mapping which has the data quality components involved in it. So for this, you will probably create an automation script to copy the address doctor files or other required data quality files on all the nodes on Hadoop cluster. A few other things, the environment variables in Hadoop env.properties, the path and LD library path. This is basically to run any mapping which has a dependency on the third-party libraries that has to be set up. With that, we complete the installation and configuration, which are mandatory steps for a Hadoop mapping to run in pushdown, for a mapping to run on Hadoop in pushdown mode. Now, let's look at the system architecture, how Informatica does a pushdown. So the data integration service has the components like mapping service, the LDTM, there is a Hive executor and a Hive driver. The mapping service actually provides some APIs for the Informatica mappings to run, and LDTM compiles the Informatica mapping into a set of tasks, and that could be executed on the Hadoop environment. And likewise, Hive executor uses the LDTM task that is created by the LDTM, and it sends queries and commands to the Hive. And Hive driver is the component which is responsible for executing the Hive queries and on the Hadoop environment. Taking an example, if you have a mapping, this is for pushdown again, so this will be on the developer side, the developer tool. if you have a source, aggregator, and a target in your mapping, there are 3 execution phases. So the data flow of the mapping will be broken down into 3 different phases. In the first phase of the source is the extraction phase, where the source data is staged into temporary Hive tables. And in the transformation phase, the stage data is read and transformed into Hadoop using Hive operations and Informatica logic. And in the last phase, which is the load phase, the results of the transform phase are loaded by the Informatica adapters. So depending on the mapping logic, multiple Hive queries could be created, and these Hive queries will be converted into MapReduce jobs by the driver, and that will be sent out to the Hadoop cluster for execution of the mapping. On the PowerCenter side, it's the terminology is Power Exchange for Hadoop. You can read and write to HDFS files, and you can also load data to Hive tables. And you can, one important thing to note here is if you are on a 9.6 environment, then should be okay. But if you are upgrading from a lower environment, then you need to register the pm-hdfs.xml to the repository. Otherwise, you might not get the drop-down or the option to create a connection on the PowerCenter environment. With this, I would, like Ravee will show the demo right now after this. He will go over how to create connections and mappings, etc.
So hey guys, this is Ravinder. I will go through the demo for this session. Let me start by going to the developer tool and so first let's take a look at the connection properties for both HDFS and Hive. So I am going into Windows preference in the connections. If you go to file systems, you will see the Hadoop file system. I have a couple of connections here. So click on edit, and if you see for HDFS, there is not much of a details here. You just need to give the name node URI and the username on the HDFS file system. For the Hive, we need to go into the databases section. There is a Hive section under the databases, and this is one of my Hive connections here. So if you see here, this is my Hive connection name, ID, etc. And in the next tab, database connections, there are 2 connection modes here. One says access Hive as a source or target, and the other one says use Hive to run mappings in Hadoop cluster. What this means is, the first one means you are going to read from a Hive table or write to a Hive table, whereas the second one is to push your mapping logic down to the Hadoop cluster. So that means your mapping will run on the Hadoop cluster. So you can use both of these or either of these depending on your requirement. So here metadata connection string, you give the the Hive connection URL, and the data access connection string. Metadata connection string will be used to access the metadata to import the table source and target, and data access connection string is something that it will be used when actually reading the data from the Hive table. So that's for, and the next tab is for the push down. So pushing the mappings down to the Hadoop cluster. So if you see here, we give the name node URI, job tracker URI for submitting this job as well as getting the status of the jobs. And in this case, I'm using the remote metastore execution mode. But if you have the local execution mode, then you will give the database URI, database driver, username, password. Otherwise, it will be the thrift URL. So that's the connection properties. So what I will do is I will run a couple of mappings, one in the native mode and one in the push down mode, and show where to look for the logs and how they run. So first mapping, this is a simple mapping. It reads from HDFS source and writes to a HDFS target. So if you look at here, this is a simple flat file physical data object, and what I have done here is in the runtime you can modify the connections here in the connection type. If you have selected this to none, this will be returned to the local node, which is the DAS machine. But I have selected it Hadoop file system, and I am giving it the source directory and the source file name as the Hadoop file system, so it will be returned to the HDFS. Same for the target. So target also I am writing it to the Hadoop file system. So let me show this input file quickly. So this is my input file. Let me run the mapping. Mapping is done here, so let's take a look at the logs one. So as you can see, like 3 records were read and 3 were written here. So if you look at our target directory on the HDFS, so you should see the records here. So that's the this is running in native mode. So if you look at the advanced properties here, the validation I have validated to be on the native and high mode. I can run it in the native and high mode. So you'll have to check both of these if you want to run it in both environment, or either of these if you want to run it in one environment. So but the runtime, depending on where you want to run, you will select whether the Hive environment. If you select the Hive environment, then you need to select the appropriate Hive connection. In this case, I am running in native environment, so I have not selected a Hive connection here. So in the next in this mapping, I will show the this is a push down use case. So basically, I will show the mapping getting pushed down to the Hadoop layer. So in this case, I am reading from a Hive table, doing an aggregation on that, basically counting the records in the table and writing it to the target. So if you look at my table here, there are 2 records in the Hive table. So the count of 2 should be returned to the target table. And again, connections wise, I have given the connections as the Hive connection, which is the CDH45 in this case. This is the same connection that we have seen earlier. So aggregator does nothing, but it again does a count. And this is again the same connection, and we are again writing to a Hive table. Yes, so in the mapping, if you look at the advanced, I have selected only validation environment as Hive here. The reason being, I can select native if I have a Hive target. So if I would have selected native here, and so I would get an error saying like Hive targets are not currently supported in native execution mode. So that is expected. So if you have a Hive target, you cannot run it in native execution mode. They have to be run in the Hive push down mode basically. So let me just select the Hive mode here. It's valid now. And in the runtime, since you have selected your execution environment to be Hive, you need to select the appropriate Hive connection or the Hive connection where you want this mapping to be pushed. Okay, so let me run the mapping. You can go to monitoring tab. Okay, it is running. So mapping is done. As you can see, it created a couple of split into couple of scripts, Hive queries. So these Hive queries will be translated into MapReduce jobs for the by the Hive driver and sent to Hadoop job tracker for execution. So if you look at the, so let me show the target table first. So as you can see, 2, that's the number of records 2 is written to the target here. We can get the logs from here. We can get the logs from here. Okay, so let me go to text pad. So here you can see the Hadoop tracking URL as well, the job tracker and everything. So you can go to the job tracker and see the what is the status. So if at all there is a failure, then that's where you will go and look for the status of the failure. So here you can see that there are 2 maps done and 1 reduced, and if you click on the map, then you will see here the under the map there are 2 maps, the tasks and the logs for each of those. You can select that. And so this is the job that got submitted, the job XML. So this will have all the Hive parameters. This is something that could be required and will be requested by us for troubleshooting purposes. Okay, so let's go again to the developer tool. So that's the push down job. So now I will show you another push down job, which is a profile mapping. So I will show you the profile and I will run the profile mapping pushing down to the Hadoop cluster. So I already have a profile here. So definition, if you see, like only there are a few columns I have selected here, and in the run settings, again similarly like how for the mapping, the profile also similar. It's again underneath it will run a mapping, right? So you need to select the runtime environment and validation environments here. So I have selected native and Hive, so I can run this profile in native or Hive mode. And in runtime environment, I have currently selected to Hive, so because I will be running it in Hive mode, and Hive connection is CDH45. So let me run this profile. Let me show the results also, because last time, so since this was not run, there were no results at this time. So once it is completed, probably we will see the results. Okay, let's go to the monitoring tab here. As you can see now, the profile mapping is running, and if you see, there are like a lot of scripts that are getting created and a lot of Hive queries underneath that got split. So this will run for quite some time. And if you look at that, it is again similar to the earlier job that we have created. It is just that its mapping is a profile mapping, so it has a lot of columns and logic there. So we can take a look at the log here. Since it is still running, it will be partial. So you can see the the queries that we are seeing in the monitoring tab right here, and so there will be a. Let me go to the DAS machine here. So if you see, there are like some Hive session logs that are getting created here. So if you look at each of these jobs, it will say like, what is the status of the map reduce jobs that are getting submitted. In this case, it is pretty much done here, map and reduce. So if you see, there is a, the job tracker URL as well that you can do. So in any case, right, so when there are issues, typically you would look in the actual mapping log, either from the monitoring tab or from the DAS logs directory, and the DAS temp directory where the Hive session log will be there. The Hive session, this will be there in the mapping log as well, and as well as the logs from the job tracker URL, the status of the job log, and also status of the job as well as the log of the job from the Hadoop job tracker URL. So if I, in this case, if I go to the Hadoop job tracker URL and use it, thus I can see that there is one map and one reduce, and if we look at that, and it is again, it is. This is the log on the Hadoop job tracking. So that's for the push down of the profile. So this is still running. If we go to the monitoring tab, some of the so it runs for like 4 to 5 minutes. So we don't have to wait for it. It will it will be done in its own time. So as you can see, in the past it has completed successfully here, and with this, let me go to PowerCenter. So in as Sushma was saying earlier, in PowerCenter, all we can do is read from HDFS and write to HDFS. There is no push down here, and we can choose to write to Hive table, but there is no reading from Hive table supported. So let me start by showing the connections. So here I have given the username and the HDFS connection URI. The Hive driver name, URL, Hive username, password, all of these are optional. These are only needed if at all you are going to write to a Hive table. If not, these need not be set at all. They will not be used. For HDFS, all you need is the connection URI and the username. However, the Hadoop distribution is a mandatory one, so this is something that you would select for your own Hadoop vendor, basically. So if you have multiple ones that you need to write and read from, then you would need to create multiple connections and multiple mappings. So if you look at the session, this is again a simple session similar to the one that we have seen in the developer tool, not the push down, but the other one where we are writing to the HDFS. So here again we select, instead of file reader, we select a HDFS file reader, HDFS flat file reader, and here we give the file path as the HDFS path. And here we connect, we again give the flat file writer, give the connection name, and give the output file path here. So the input file is same as whatever we have seen earlier, just the output file is different. So let me quickly run this. It looks like there is some problem connecting to the workflow monitor here. So let me see if we have already. I would just like to show the property. So writing to HDFS is similar to developer tool that we have noticed it, right? So it is nothing different. It will just try to. So only another thing that is different in the PowerCenter is there is a choice that you can select. There is a checkbox that you can select to write to Hive table or not. So that is, I will show you that part here. So in the target properties, so if you see here, generate and load Hive table, overwrite Hive table, this is something that you will select if you want to write to the Hive table as well as HDFS. In this case, what will happen is it will write to the output HDFS directory, and after that it will move the file over to the Hive warehouse and copy it to the table. So you can give any table name here. Okay, so it seems to have been fixed the issue, so it's running now. And as you can see, the 3 records that we saw earlier, it's done. So I would just like to show the session log. There are like, so if you notice here, it has, after like loading to the HDFS file, it will run these tables, it will run these Hive statements for creating the table that we have specified, in this case which is sample underscore Ravee2 and load. So this data from the temp output 1.txt will be moved to the Hive table. So if we look at the Hive table here, so this is the same from the input.txt. So that's about it for the demo. Thank you.
Thank you so much, Sushma and Ravi, for the wonderful presentation and the demo. We will open up the bridge for Q&A now. So if you have any questions, you can post it through chat. The user that you need to post the questions is Patabi Raman. And
presentation mode is now disabled.
And if you have any questions on the phone as well, you can bring those questions up. I think we have the next 10 minutes open for questions. I think we have one question on chat. I think this question was asked by Bhujan. Can we run jobs in HDFS from PowerCenter?
Bhujang, if you meant like, can you push down the mapping and run PowerCenter mappings in push down mode, then the answer is no. Push down mode is only possible from the developer tool.
I think we have another question here from Ashan. The question is, can we read unstructured data to in 9.6 developer or PowerCenter and process it through Hadoop?
Yeah, in 9.6 you should be able to read unstructured data also. Like we have those complex files that you can, objects that you can create, and you should be able to do the unstructured data processing.
Hi, hi, this is Ashan.
Yeah, I think you're asking if it's JSON or an RSS feed, right?
For the complex files, right? So JSON is natively supported right now by the data process transformation.
Yeah.
So even the RSS feeds, it depends on the logic has to be built into the data process transformation. Once that is done, then we should be able to push it down the Hadoop layer.
And is this feature going to be available from 9.6 or is it available in 9.5 too?
It will be in 9.6 onwards.
We have another question from Sudhir. What is the difference between PowerCenter developer tools and developer tools shown in the demo?
So the PowerCenter is the traditional PowerCenter that we have been working with, right? So developer tool is a new platform which uses the MRS and the DAS. So this is a completely new platform. So the difference-wise, as far as this session is concerned, Hadoop is concerned, we can only read and write to HDFS from PowerCenter. Whereas in developer tool, we can push the mapping logic down to the Hadoop cluster.
Another question from Rohit. What are the limitations of running a traditional mapping now on Hadoop?
Rohit, do you mean like, when you say traditional mapping, is it the PowerCenter mapping? I'm not clear on that. Okay, so PowerCenter mapping, you cannot push down, like I said, you cannot run the mapping itself on, you cannot push down. So you can but use HDFS or high-res source target.
So again, limitations-wise, right? So it is just like any other PowerCenter mapping. If you notice the mapping, it will be like a flat file reader and writer, because that's how so you can have pretty much any transformations you want to in the mapping.
We have another question on chat for unstructured data processing behind the scenes. Do we need to write the same DT code, or is the B2B data transformation being incorporated into the PowerCenter developer?
B2B data, can be written in the developer tool as well now. But either way, if you written in the studio or developer tool, it is the same. You still need to write the IntelliScript code to parse the data. But you can do the IntelliScript development, the B2B DT project development itself in developer tool now.
Another question, are all transformations from PC mapping supported on Hadoop?
So the answer to that is mostly yes, but there are, yeah.
Developer tool, there are certain limitations. I think those limitations should be there in the documentation. They should be mostly for push down, but for the normal mapping that you read from HDFS and in PowerCenter, that should be there should be no limitations. Pretty much all the transformations there.
I think we should be able to take a couple of more questions. we have 5 more minutes before we come to the end of the webinar session here. I think we don't have any further questions either on chat. Oh, okay. I think we have one final question here. I heard sequence generator transformation is not supported on Hadoop. Is that true?
Sequence generator transformation. There is no sequence generator transformation in the developer tool as of now. So there is a UUID is the new thing that came in PC 9.6. That is something that can be leveraged to push it down to the Hadoop. That is the UUID.
The alternative is the UUID. All right, I think we have come to the end of the webinar session here. Thank you everyone for joining us, and the recording of this particular webinar will be available on our YouTube channel. So, and we'll also be updating the blog post on our MySupport portal. The YouTube channel is INFASupport, that's INFASUPPORT. Thank you everyone, and thanks a lot Sushma and Ravee for the wonderful information that you shared today. Thanks everyone. Have a good day and a good weekend.